This is day 1, video 2. We're starting on page 3 of the packet. We have a third-degree polynomial given, and it tells us in the problem that this function outputs revenue in millions of dollars per day, and tells us that the input, N, is the thousands of employees working that day. It also tells us that this function only works for up to 13,000 employees in a day. So although it does not say to do so in like a part A or something, I always, before I dive into a problem, carefully sort out the meaning of the input and output. I may even produce a graph. Now I've already put the graph here for you, but I have not labeled it. So let's go ahead and do that before we dive into the problems. The input is N. So the x-axis should be N. And I'm also going to label here the meaning of it. It's thousands of employees working that day. So each of the numbers along here represents thousands of employees. So for example, if this was 1, it would represent 1,000 employees. And the output is R of N, revenue in millions of dollars. So again, if this first tick mark here were 1, it represents $1 million of revenue. It tells us in the problem that we're only capable of employing up to 13,000 employees. So that means you should only graph up to N equals 13, which would represent 13,000. So what we see here at the very end of this graph is N equals 13. The very beginning of the graph is N equals 0 because the lowest number of employees you could possibly employ is 0 employees. And then I produce the graph from there. So it asks us in this problem to find or solve P of Q equals 200.4. So the y value, the height, is 200.4. Now this is a problem I would expect you to solve graphically using technology. You're not going to do this with any sort of algebraic solving. We're going to use Excel to do this starting in the next class, but for now, you could do this using Calc Intersect on your calculator. You could put in y1 equals the original function, x cubed minus 19.5x squared plus 102.5x plus 16, and we're trying to find when it reaches a height of y equals 200.4, and then your viewing window, our low x min is 0, our high x max is 13, and you could then hit zoom fit or zoom 0 to set the y window. And you should see a graph like this. Finally, you use a Calc Intersect on your calculator to find when the horizontal line at y equals 200.4 intersects the function. You should see a horizontal line approximately here. That's your line y equals 200.4. It intersects the function over here on the right side of your graph. And you should see that the intersection occurs at approximately 12.4627, and the y value is 200.4. So it's saying when 12.4627 thousand employees, so 12,463 employees work, the 200.4 is the revenue in millions. They have revenue $200.4 million. Then it says to find the company revenue when employing 8,564 employees. Again, in this function, N is thousands of employees. So 8,564 means N equals 8.564. 8.564 in thousands is 8,564. So we go to the function and we plug in N equals 8.564. When you do that, you should get R of 8.564 equals 91 point, I got 740838. So I'm going to take it out that far just so we can give a lot of accuracy. It's saying when 8,564 employees work, the revenue is $91,740,838. And that again is if we round to the nearest dollar, which is pretty accurate for a model, but still, that is literally what it would mean. The next function, it says we have a function R of A in the graph. It says it gives us projected revenue in dollars. So I'm going to go over here and say it's outputting revenue in dollars, labeling it, sorting out meaning of input and output. It says it's giving revenue in dollars when spending $A per day on advertising. So the input is $A per day on advertising. So it said to label both the axes, so I've done that. R of A is our output, A is the input, and I labeled the meaning. Part B, estimate the revenue when they spend $30 per day. So $30 per day means 30 on the input axis. I'm going to take that up until it intersects the function. It's about right here, and ask what is the approximate estimated height. Looks like it's definitely below 50,000. Why don't I say it's approximately 40,000 in revenue. Approximately, it's an estimate. You may estimate it slightly differently than that. Then part C, estimate the advertising amount spent when they earn 70,000 in revenue. So I need to locate 70,000 in revenue. So that should be between 50 and 100,000. It's below the halfway point between those two. So maybe here. Here is 70,000 in revenue. I take that over until it intersects the function about right there, and take that down to ask approximately what is the input advertising amount. And I'm going to guesstimate that's about $35 per day in advertising.